Okay, today we're going to be studying about transformations of quadratic graphs. These are the content standards and the mathematical practices we'll be using for our assignment. So previously you've transformed graphs of functions, and today we're going to write a quadratic function in the form y is equal to a times the quantity of x minus h squared plus k, and we're going to transform graphs of quadratic functions in that same form. One new vocabulary word today, vertex form. So the function y is equal to a times the quantity of x minus h squared plus k is written in vertex form, where h and k is the vertex of the parabola. X is equal to h is the axis of symmetry, and a determines the shape of the parabola and the direction in which it opens. Now, when a quadratic function is in the form y is equal to ax squared plus bx plus c, you can complete the square to write the function in vertex form. Remember, if the coefficient of the quadratic term is not 1, then factor the coefficient from the quadratic and linear terms before completing the square. After completing the square and writing the function in vertex form, the value of k is indicated. A minimum value if a is less than 0, or a maximum value if a is greater than 0. So let's see what this means. We're being asked to write y is equal to x squared minus 2x plus 4 in vertex form. Notice that we've got a perfect square here. So we could take half of 2 and square it. That's a positive 1. And so what we're going to do is subtract 1 from the other side. So imagine that that was a negative 4, and we'd be adding 1 to it, and then we moved it back, we'd be subtracting it. So you're going to, if you add it in here, you're going to subtract it from the constant. So we're left with y is equal to x minus 1 squared plus 3. So that is our answer written in vertex form, where we've got an h and a k. Now let's look at this one. Notice that our coefficient with our quadratic term is not a 1. We've got a negative 3. So out of these first two terms, we're going to factor out a negative 3. That leaves us with x squared plus 6x. Now we're going to complete the square. Half of 6 is 3. 3 squared is 9. So if we're adding 9 here, we're going to be subtracting 9. But remember, this is not just 9. If we were to multiply it by this negative 3, we'd have a negative 27, right? So if we're multiplying it by negative 3 here, we also have to multiply it by negative 3 here. That leaves us with negative 3 times the quantity of x plus 3 squared plus 37. So that's that function written in vertex form. All right, time to check your progress. So pause the video for a moment, work the problem, then come back and check your answer. Okay, y is equal to x plus 3 minus 4. Well, this is not a perfect square, so we have to take half of 6, which is 3, square it, plus 9, that's going to be inside parentheses, which means we're going to subtract 9 from this side. That's how we get y is equal to the quantity x plus 3 squared minus 4. Let's try another one. This one with a is not equal to 1. Okay, so we're going to factor out a negative 3. That's going to leave us with x squared plus 6x. Take half of 6, which is 3, and square it. So x plus 3 squared, and then to the 4, we're going to have to add to it a negative 3 times a negative 9. That will give us negative 3 times the quantity x plus 3 squared plus 31. If the vertex and one additional point on the graph of a parabola are known, you can write the equation of the parabola in vertex form. Okay, so looking at this example, the vertex is at 2, negative 3. So h is 2 and k is negative 3. Now, since the graph passes through 0, negative 1, we're going to let x be 0 and y equal -1. And we're going to substitute these values into the vertex form of the equation and simply solve for a. Okay, so we said that the vertex was 2, -3, and that it passed through point 0, -1. So -2 squared is 4. So 4a minus 3, well, if we add 3 to both sides, we get 2 is equal to 4a. So a is equal to 1/2. So we can rewrite the equation in vertex form. Y is equal to 1/2 times the quantity of x. We're doing -2 because the vertex is at 2, -3. So the answer is B. Okay, time to check your progress. So pause it for a moment and identify the vertex and where it crosses the where the graph crosses the y-axis, and then substitute that into the equation. Okay, so it crosses at, the vertex is -1, 2, and it crosses the graph at 0, -1, just like in our example. So I substitute in -1 is equal to a times 0 minus a -1, square that, plus 2. When we solve for a, we end up with a is a -3, and we know that our vertex is at -1, 2. In lesson 2.7, you learned how different transformations affect the graphs of parent functions, and this concept summary simply summarizes these transformations for quadratic functions. So take a moment and pause and look back at it and remember what we discussed about horizontal and vertical translations and reflections. And now we're looking at dilations. So we're asked to graph equations in vertex form. So let's rewrite the equation in vertex form. So first of all, a is not 1, so we're going to pull out a -2. That leaves us x squared minus 2x plus 1. Complete the square. So half of 2 is 1, and 1 squared is 1. And notice again, we're multiplying this by -2, so we have to multiply this side by -2, and we're going to subtract 1 from both sides. So 1 minus a -2 times 1, that gives us a +2 plus 1 is 3, and this one factors as x minus 1 squared. So the vertex is at 1, 3, the axis of symmetry is at 1, and because a is equal to -2, we know the graph opens down and is narrower than the graph y equals -x squared. So we plot additional points to help us complete the graph. So following the same steps, I want you to check your progress and graph this equation. Which one matches? Okay, so if you factor out a 3 out of both of these, that's going to leave us with x squared plus 4x. Half of 4 is 2, 2 squared is 4, so we're going to keep 4 inside the parentheses, and to the 8 we're going to multiply it by a -3 times 4. So we're going to have a -12. That's going to leave us with 3 times the quantity of x plus 2 squared minus 4. So we know our vertex is at a -2, 4. Well, that rules out a -2, -4. Oh, here we go. -2, -4. The axis of symmetry is at a -2. A is 3. So the parent function y is equal to x squared. So it must be B. Okay, you're ready to begin your assignment. Good job.